Hello everyone, in this video I want to go over example problem number 3 because we didn't actually get to cover it in the last video, so I want to cover it here, and then after I will transition into the last topic of our note this week, which is combined gas law. So let's take a look at example number 3 here. I was given a sample of gas at 15 degrees Celsius and 1 atm has a volume of 2.58 liter. Then the temperature of this gas is raised and the volume expands to 3.04 liter with a pressure of still 1 atm. What is my new temperature? Now, when you look at this kind of question, you want to look for what is given to you, what kind of information is given to you. And I'm already seeing here that I'm given a temperature and I'm also given a volume. And then I'm actually given another volume value. All right. Now I also see that another piece of information is given to me is pressure. And here's 1 atm. But I want to point out that this pressure remained constant throughout the entire thing. Meaning that it's 1 atm at the beginning, and then after the temperature is raised and the volume expands, the pressure remains the same at 1 atm. So because the pressure remains what we call constant or doesn't change, we don't want it in our equation. The rule of thumb is that when a variable remains constant, it does not appear in the equation. So because of that, I know that I have to choose an equation that has temperature and volume. And the one that has temperature and volume is Charles' law. So that's why I have right in front of you is Charles' law. I'm going to erase these here just so that I don't confuse you. Now I have identified here that I have one temperature value, one volume value, and another volume value. Now I have to identify though which one was my initial. Is it this one or is it this one? And which one is my final? Because recall from the last video, the subscript here has a meaning. So V1 and T1 has its meaning and V2, T2 has its own meaning. And recall what it means in terms of whether it's the initial and which one is the final. And then answer the question now. Hopefully you said that V1 and T1 is our initial. So V1 is initial volume and T1 is initial temperature. V2 is our final volume and T2 is our final temperature. Now, first of all, then let's tackle this problem by first identifying the given. And what's given to us is V1 is 2.58 liter. And T1 is 15 degrees Celsius right here. And you want to convert that to Kelvin by simply just adding 273, giving me 288 Kelvin. What's left is the other volume here, 3.04, and that's our final volume because that's the one where after we raise the temperature, the volume expands to. And lastly, our missing variable is T2. Now, after you have identified the missing variable and the given variable, what is your next step? Go ahead and answer the question now. Hopefully you said that you need to rearrange the equation to solve for a missing variable. So there's a couple ways of going about this so you can rearrange this equation to your favor. And my favorite way is actually the crisscross method. So what I'm going to do is I'm going to multiply it like so. And this would give me V1 T2 is equal to T1 V2. And then, because I know I want T2 to be alone, I want to divide both sides by V1. And that would cancel out V1 and giving me T2 equals to T1 V2 over V1. Just like that. And here we are, we rearranged the equation to solve for T2. This is what I got. And then you just plug in the numbers and solve. When you plug in a number, you should get 339 Kelvin. Now keep in mind that even though this answer is in Kelvin, the temperature you were given at the beginning is in Celsius. So what this means is that you're going to have to convert this back to Celsius. And you're going to do that by just subtracting 773, giving you 66 degrees Celsius. And this is very important to remember that whatever unit of temperature you were giving in the beginning, you need to have that same unit of temperature at the end. All right, let's talk about combined gas law. Now, this law is for conditions where the number of moles is constant, but the pressure, volume, and temperature are changing. So remember, the rules of thumb from before is that whatever variable is constant, it doesn't pop up in the equation. And in this case, the moles is constant, so it doesn't pop up in our equation. But pressure, volume, and temperature do change. So that's why they are in this gas law equation. Let's take a look at an example of how you can actually use this to solve a problem. Let's take this for example. You have a sample of gas and it has a pressure of 1.588 atm at a temperature of 115 degrees Celsius and a volume of 13.06 liters. If the temperature is raised to 143 degrees Celsius and also the pressure increases to 2.616 atmosphere, then what is the new volume? Now, I know that I need to use the combined gas law because I'm seeing these pieces of information right here. I'm seeing pressure right here. That's pressure. I'm seeing temperature. That's T. I'm seeing volume. That's V. I'm seeing also another temperature. So that could be our T2. And the pressure increases to this much. That is another pressure. So I can say these are my initial. So PT1, P1, and V1, because that's what we started with. And then the other two variable I just named T2 and P2 is what we end with. Now they're asking us what is the new volume. Now whenever you see that you are given all three of the variables except for moles, you know that you have to use combined gas law. So this is my combined gas law, and we are looking for the new volume. But first, let's do it step by step. Step number 1, identify the given variable and the missing variable. So I have already kind of did that in the question, but I do want to write it out explicitly just so that I don't lose numbers anywhere. So I have P1 to be this number, V1 to be this one, T1 is 388 Kelvin, making sure that you always convert to Kelvin when you're working with temperature. And then P2 is this number right here. V2 is actually what is asked of us, so that's our missing variable. It's asking for what is the new volume, and whenever you say new is a good indication that V2, or a variable with a subscript 2. And then T2 is 143 degrees Celsius. You convert that to Kelvin, you get 416. Okay. So after you have identified your given and your missing variable, you want to rearrange this equation right here in order for you to isolate V2 so you can solve for it. And after you rearrange this equation, you get this, where you have V2 is equal to P1 times V1 times T2 over T1 times P2. When you plug in your equation and with the given variables, you should get 8.500 liter.